Okay, this video will be on scientific notation, just a short way to represent very small or very long numbers. Definition of positive number expressed in the form of a times 10 to the nth power. Just want to start right there. I was writing the definition I saw in the book, and you can represent negative numbers this way as well. Just depends on the application. So that's what I was writing here as far as the notes are concerned. But it's a positive number expressed in the form of a times 10 to the nth power, where a has to be in between 1 and 10. Now it can be equal to 1, it cannot be equal to 10, and n is an integer. The exponent is an integer. It can be negative or positive, cannot be a decimal or a fraction. So how we write a scientific notation? Let's say if I have 53,000 and I want to write 53,000 in scientific notation. But first I need to put the decimal in a place as far as these digits are concerned that will create a number that's in between 1 and 10. So I will look to put my decimal in between the 5 and the 3. That will give me 5.3. If I put a decimal right here, that's going to be 53, which would be larger than 10. If I put the decimal in front of the 5, that will be 0.53, which will be less than 1. So you put the decimal in between the 5 and the 3 to give you 5.3, and that will give you the number that's in between 1 and 10. Then you count how many decimal places did you go in order to get there. So since we didn't see anything, they assume you know it's to the furthest of the rightmost digit. So we went over 4 places to the left. So that's going to be 5.3 times 10 to the 4th power. All right. So this next one, we have 0.000074. Once again, I want to create a number that's in between 1 and 10. So that means I'm going to put the decimal in between the 7 and 4. So I see my decimal here and I move it 5 places to the right to get it to 7.4. So that's going to be 7.4 times 10 to the negative 5th power. So notice going to the left, move my decimal to the left to convert to scientific notation. My digit should be positive. My exponent should be positive. Take it positive, moving it to the right. My exponent should be negative. So let's try it again. We have 893 million. So move your decimal 8 spots to the left in order to get this between the 8 and the 9. So I have 8.93. And since I went 8 to the left, that's going to be times 10 to the 8th power. Here we have 0.0000001234. The decimal needs to go in between the 1 and 2 to create a number in between 1 and 10. So that would be 7 decimal places to the right. So that's 1.234 times 10 to the negative 7th power. And then we're going to go the other way with it. Write the numbers in standard form. They're in scientific notation. Then we want to convert them to standard form. So we reverse the process. I have 1.67 times 10 to the 6th power. Since there's a positive exponent, I want this to have a positive effect on that 1.67. In other words, it should be greater. So I move my decimal 6 places to the right. If I do that, 2 of those places will be taken up by the 6 and 7. The other 4, we will use zeros as placeholders. So that'll be 1670000. In the next one, 3.552 times 10 to the negative 3rd power. Since it's negative, I want to have a number that's smaller. I want to have a negative effect on that 3.552. So I want a number that's smaller. So I'll take my digits, my decimal to the left, 3 digits. So we go 3 to the left. 1 spot is taken up by the 3, and then the other 2 spots we use placeholders as zeros for them, and that'll be 0.003552. So we have 9 times 10 to the 4th. That decimal is to the right of the 9, moving 4 places to the right. So that would be 4 zeros behind that 9. And then last one, 4.8 times 10 to the negative 5th. We move that decimal 5 places to the left. The 4 will take one of those spots, and then we use zeros for the other 4. And that'll be 0.000048. Let me know if you have any questions.